let's remove everything that was there before. We also need to set boundary condition for this. When this is moving, we cannot have this kind of a boundary condition. We should have a moving wall velocity with the value equal to 0. The velocity will be set using the mesh motion. Now let's run this. It is asking that there are no bodies defined in the dynamic mesh dict. That means in the dynamic mesh dict, it requires bodies. Let's see how we can define bodies. We have to define bodies, which is a square. The type we want here is of type rigid body, and the parent is root. We have to define the parent. For example, if we want a body which is moving and it should move with the parent, the body is kept on a disk and the disk is also moving, so it will move locally according to whatever motion we are setting, but it has a parent which will follow as well. Now we have to set some inertia and velocity and various other things. Let's see what various other things we require. We'll go to the source code again. Now we'll look at this. We are doing a rigid body motion solver. We'll go to a rigid body motion solver. Let's go to that. Here we have a rigid body motion solver. This requires all these, and there's a mesh motion which requires this. It requires the inner and outer, how it is going to morph. Let's set that as well. Here it requires the patches, and it is subclass from displacement motion solver, which is not here. Let's go here, and probably this will require bodies motion solver, this rigid body model, and this has a friend class which is a rigid body solver, which we just saw here. And in the rigid body model, you will see all these bodies, the body IDs, the joints which are required. So what we are going to do now is we'll set these basic things which are required in bodies. Let's see what are required in the bodies. In the bodies, we require just the name and whatever is required in the rigid body inertia, which is the mass, the center of mass, and inertia. Let's set that. The inertia should be symmetric. We just require 6 values. Let's set any 6 value, 0, 1, 0, 0, 1, 0, 1, because this is not a real simulation. Let's set mass equal to 1 and center of mass equal to this. Our center is at 5,5. We'll set this to say 4,4. And now for the bodies, we also require joints. Let's see what are joints. We have joints here. These are all the joints. Joints are of type composite and floating. These are all the values. This is the joints.h file, and these are the revolute. These are the prismatic joint. We just need a revolute joint of type composite. Let's see what is composite mean. This is the prismatic joint for transfer along the specified arbitrary axis. Let's do that. We want to set this as type composite with joints as type RC. If this is done, we have defined the joint, then we can come out of it, which is the rigid body model. Let's come out of it. This is the rigid body motion. For the rigid body motion, we can set a damping as well. We can switch this as well. Let's go again to rigid body mesh motion, which is this. We have a rigid body motion model. We have already set this. Then we require the rho inf and rho. Since this is incompressible, probably it is written somewhere here. If it is incompressible, you have to define that rho is equal to rho inf and your rho inf value, which is 1. In the rigid body motion solver, we need di and do as well. Let's see what these means. You can go to the .c file and see what it is looking for. DI looks for inner diameter and DO looks for outer diameter. You also have to define patches. So let's go back here and define these. Yeah, the inner diameter should be, let's define this as 0.3, and the outer diameter, let's define this as 0.0. Patches we can define as square. Let's see what else do we need. In here, this is of type displacement motion solver, which is here. This is a motion solver. Let's see what motion solver requires. The motion solver, it requires this coefficient dictionary and the mesh. Let's go back here and let's see how do we set the solver. In the rigid body motion, we need a rigid body solver as well. Yeah, this rigid body solver needs to be declared. Let's see what are the types here. So in the rigid body solver, we have all these kinds of solver, which is Nicolson, Newmark, and Symplectic. These we should pass. So let's go back here. This should be the solver, which is here. Let's see what do we need here in the solver. Just the name of the solver. You can just go back here. You can see here that a subdictionary is required. The solver should be in the form of a subdictionary solver, and then type Newmark. Let's use Newmark solver. Let's first clean this. It won't run for the entire time because eventually when we move the body, the mesh is going to distort and it won't solve everything.